So it's lesson 10. We're going to get our feet wet with Angular 2. So one of the first things we need to do is we need to make sure that we need to talk a little bit about TypeScript. So here's the home page. Did anybody catch anything from the video about what TypeScript is and why we're going to use it with Angular 2? Like, why don't we just write all our Angular code in? We could write it just in ES5, but typically TypeScript is used.
Because Angular 2 is built on the basis of TypeScript.
Okay, so that's one reason to use it. Yeah, the Angular source code itself is written in TypeScript. Anything else? Why did they write it in TypeScript? Why didn't they just write it in ES5 or ES6?
More features, better documentation.
Okay, what are some of the features of TypeScript? So the big classes is one, that we can define a class in TypeScript. We can't really define a class so easily in vanilla JavaScript. Is JavaScript strongly typed or loosely typed? It's loosely typed, right? When we want to create a variable, we just use var or let. We make that variable, it has no data type. TypeScript, as you can imagine, is a typed, strongly typed superset, so version of JavaScript. So all of the same commands, we can still use all of JavaScript, but then TypeScript has its own set of commands on top that gives it much more structure. So that's what we're going to use. So to see how this works, let's install TypeScript globally. So if you want to open up a command prompt, I'll just go into my node folder for the course. Doesn't really matter that we're going to do a global install. So it doesn't matter what directory we go to. The TypeScript is available on NPM. So here's our install command. npm install -g TypeScript, or TypeScript -g. So let's install it globally. So we're going to write our Angular code in TypeScript. So we're going to create files with .ts extensions. From the command line, once we install TypeScript, there's a compile command. So we can compile it. And what the TypeScript compiler will do is take our TypeScript file, convert it into JavaScript, and create a .js file with the same name, with our code being converted. And if we're using something like WebStorm or Visual Studio Code, those editors have TypeScript compilers built into them already. So the way to check, I'm not going to run the install because I already have it. The way to check if TypeScript got installed is just now run the command tsc, that stands for TypeScript compiler, -- version. If we do this, we should get version 2.2.1. So if we have version 2.2.1 installed, it means we can then write TypeScript files and compile them to ES5. So I get 2.2.1.
Why it's not like a dependency for Angular NPM?
Sorry?
Why we have to download separately TypeScript? I thought we can just like download or install Angular 2 NPM and do not worry about TypeScript.
Well, we may want to run TypeScript. For example, we're going to build a TypeScript file right now and compile it without Angular. Okay. So if you're in your node folder, I'll just go into my folder for the course. We're going to make two folders. We won't make a lesson 10 folder yet. We'll make that next. For the moment, just make a new folder and call it TS test. We're just going to try a TypeScript example without Angular, but we still want to be able to compile it. So create a TS test folder. And in here, let's make a new file which we'll just call sample.ts. Doesn't really matter, you can give it any name. Sample.ts. And I'll just open this up in WebStorm. I'll open up my TS test folder. We're only putting one file in here. We just want to make sure our TypeScript compiler works and see what it looks like. So open up your code editor, WebStorm, Visual Studio Code, whatever you're using. And we'll just open up this little TS test folder. So we've got, so notice as soon as I open it up, there's not even any code in here, but look at what WebStorm's asking me. Should we compile your TypeScript to JavaScript? I could say okay for now. It's not going to do anything because there's no TypeScript written. So let's try a really simple TypeScript. So far, it looks like regular JavaScript, so we're going to have two parameters. If this was regular JavaScript, our function would look like this, right? We have an X and a Y. In TypeScript, remember, things are strongly typed, so we give our two parameters data types instead. And then our function also returns a number. And now in here, we can just write a regular JavaScript function, you know, return X plus Y. And we can still write regular JavaScript statements like return, console log. All this stuff still works in TypeScript. But our parameters are strongly typed and our function is strongly typed, which we couldn't do in regular JavaScript. So now if we go back to our command prompt, if I go into my folder, I'll change directories into my TS test folder. We now want to run the TypeScript compiler, which will compile and generate a JavaScript file from our TypeScript. So we can run the command tsc and sample.ts. So compile this file. So this is why we need to do it. If we didn't install TypeScript separately, we'd have to use Angular in order to do this. So we're leaving Angular out for the moment. So tsc, our TypeScript compiler, compile sample.ts. Here inside of WebStorm, it now gives me a little arrow which I can expand, and underneath it, the TypeScript compiler has generated a vanilla ES5 JavaScript file with the same name, and it converts our code to regular JavaScript. So we need to run this because our browser, your browser can't run a .ts file. Browsers don't understand TypeScript. They only understand JavaScript. But we're going to write our code in TypeScript so that we can use the structure, the classes, the data typing that TypeScript offers.
So the data typing is enforced when you're writing the file, but not necessarily running the file?
Right. So what this does is it catches many of our errors when we're coding. Right. If I do... If I try and compile this file now, I'm not going to be able to. So let me just save the change. First of all, my editor's already telling me there's a problem. But if I try and compile it again, it gives me an error. So when we're writing vanilla JavaScript, because it's so loose, doesn't have that structure, that strongly typed structure, if we make a mistake with these kinds of things, typically we only catch it when the application crashes at runtime when people are using it. So by coding it in TypeScript, this allows us, it gets a lot of the debugging out of the way before our application ever gets pushed to the server. So we're going to write all our files. When we're dealing with Angular, we're writing them in TypeScript. So we don't have to. We could write it all in JavaScript, but the standard practice is to use TypeScript instead. Any questions so far about this our little sample?
What if you created a function and your parameters were typed as number, and then when you're adding the type there was different?
Well, we do this. Now it's already telling me, my editor already knows that isn't going to work, right? Because my function's trying to generate a number where it's going to concatenate. We can try it, see if it will compile. But you're not allowed to do this because we've written it in TypeScript. So again, it's caught our error. Well, that would have to be a string. Now it'll compile, right? Now it's valid. Well, not yet, because this is invalid, right? So now that's got to be a string. I mean, it's called TypeScript for a reason, because it's emphasizing data typing, which is one of the main things JavaScript is missing. Now it compiles when I get all of my types. In effect, it's an add-on to JavaScript so that we can write strongly typed JavaScript. And the compilers will still generate it as vanilla JavaScript, but we're going to code it in a more structured way.
Do we have to compile AS file each time when we change something?
Angular will do it for you. When we install, Angular has kind of like Express has the generator that scaffolds an application and compiles. Angular has a similar thing. We'll run a command, it will build out an application scaffold, and in there, there's a package. And now they mentioned in the video using something like Grunt or Webpack. What we get from the Angular site will be a tool called Webpack, and it does recompile and recompilation, hot reloads. So we don't need NodeMon when we change our Angular code. Webpack will do it for us. Or we could use an automation tool like Grunt, he mentioned in the video. Okay. So we're going to go through on the Angular site. So here's the main Angular site, angular.io. We need to install Angular globally. So Angular, there's a package called Angular CLI, CLI standing for Command Line Interface, that will allow us to create, compile, and launch an Angular application, kind of like an Express generator, except it's just front end only. So I'm going to go back out of my TS test directory. I'll do cd ... to go up one level. So now I'm back in my main folder for COMP2106. This is where I have all the different lessons. So just like with the generator, where the generator builds a folder for us, the Angular generator is going to do the same thing. But we need to first install Angular, and we'll want to install it globally. So what we want, I'll just look it up here. Here's the package. We want to do a global install. We can see it includes this tool called Webpack for doing restarts, compilation, etc. So here's your command. I'm not going to run it in my command prompt, but I want you to run it. So do npm install globally Angular-CLI.
I think that's the old package. If you go to Angular CLI, actually CLI.angular or something, it's now at Angular/CLI. That's now they are release candidate 4.
Okay.
If you go to the site itself, you can see.
Thank you. So yes, this is the newer version. Well, it's a release candidate, sorry. So at Angular CLI. But it does say you need node 6.9 or higher. So we'll do this one. npm install -g at Angular/CLI. Thank you. May as well use the more current version. This will take a while to run because it's going to install a whole massive load of dependencies. So it will probably take a couple minutes to install all of this. Now, if we look at the docs, this is actually fairly similar to what the Express generator does, right? If we want to make a new application with the Express generator, we run the command express, the name of the application, then when it's done, we change directories, we go into the new folder, and we normally would run npm start and it kicks off localhost 3000. So this is similar. We call ng. So most of the Angular commands start with the prefix ng. So we're going to run, when this is done, ng new, and we'll build a lesson 10. Then 10 folder, and to kick it off, we'll call ng serve. File everything, and launch a local web server on port 4200. It will also automatically watch for changes. So we can change things and it will recompile. Okay, so it's finally done. So let's generate a new Angular project. So we'll follow these, just replace project name with lesson 10. So we'll do an ng new lesson 10. So build a new Angular project. It's going to take a while because, again, it installs a whole lot of stuff. There'll be tons in the node modules folder. Fortunately, it will also automatically create a git ignore and make sure node modules is included in the git ignore. So we don't have to do that manually. So we can see what it's creating. It creates a package.json like the Express generator, creates a TypeScript configuration. There's our git ignore. And it will create one component that it will call an app component. And these are TypeScript files. So this is where most of our application logic is going to go. It builds out a home page and style sheet. So kind of similar to what the Express generator does, except this is all HTML, CSS, and TypeScript. There's no back-end code. It's all front end. But now it wants to install all of the stuff that's in package.json. If we take a quick look, so I'm going to open it up. So I'm going to close this. I'm going to open up my lesson 10. It's still building it, but the folder's created, so I should be able to at least open it in my code editor while this runs. So if we look in package.json, here are all of the dependencies. We have a bunch of Angular stuff.
Yeah,
So this isn't going to work at the cottage on the dock.
Looking at the files, like when it says they're all installed. Oh, no.
like engine, so it's on the individual project.
Yeah, it'll take a while.
Yeah.
When I look in it also creates this source folder. So here's our main page, our index page. And this is where our Angular code goes, our TypeScript code to manipulate, to load certain HTML templates and to manipulate parts of the page. That's what we're going to do in here, primarily in our app component. That's where most of our front-end logic goes. And then our component will get injected or inserted into our index page. This is going to take a little while to run. So we'll just let it chug along.
So mine finished, but it didn't show up in the folder.
What engine? You need the folder.
Did it make a folder
Engine.
when you did ng new?
I did COMP 2016 lesson 10.
And that directory didn't get created?
No, but it says successful. Now, all I did was
Did it say it's creating all of these?
Yeah.
That's interesting. Make sure you're looking in the right directory.
Yeah, but
It will take several minutes to complete.
yeah, like it's finished. It says it's finished.
See, mine's not done yet, and I probably started mine before you started yours.
Oh, just put it in my users folder.
So it's just not in the right.
So you have to direct it when you name it?
Well, no, it'll create it in whatever folder, wherever you run the command.
I made my desktop side and I made a folder called Angular and then I did the lesson 10 inside of that. And then you just put it back at where users was.
You can run it from anywhere, as long as it created it. So it's finally done here. And now I'm back. It says my project was created. If we look in node modules, there's tons of stuff. Massive amount of dependencies. And now to kick the application off, I can run the command ng serve. Now, before it serves it, it's going to have to compile all the code. I run ng serve. I probably should upgrade my node. You have to be. Now I'm going to go into my lesson 10 folder. I forgot to go into that folder and run ng serve from there. That starts the application. It compiles it. You can see it's compiling. And when it's done compiling, it will load local web server. Use Webpack to start the server and monitor for changes. It's like doing npm start or the nodemon command. So it's using Webpack. Says my compilation was successful, and it should pop open a browser tab at localhost 4200 in a minute. Although it did warn me my version of Node is too old and I should upgrade it if I'm going to use this version of Angular.
I never notified you on that, but it does work. It just didn't open it right at the end, like once it was
Okay.
Webpack compiled successfully. So I just had to type in.
All right. Well, I'll try that. Maybe I need to do that too. Let's see. Okay, now notice it flashed, right? When I first loaded it, if you saw, the page said loading, and then that loading goes away, and it says app works. So we've actually got two different HTML kind of templates here. So it didn't actually pop open the window. I manually had to open a tab and browse to localhost 4200. So let's kind of look at where this stuff comes from. The page that loads originally is this one here, this index.html, right? It has my title of lesson 10, but notice all it shows is loading. There's nothing else here. So when I first loaded it, the word loading ... that showed up briefly in my browser for a minute, and then it was replaced. So where do you think the HTML that replaced it lives? So here we have an app component HTML. So this is our template. So the index, that's the whole page, but this app root, this is letting us load a section in here. So here's what loads. We just had an H1 tag. And remember we said we're going to replace our EJS with HTML and Angular on the front end? So this is what an Angular variable looks like. Instead of the percent tags like we use in EJS, the angle brackets and percent, we use this syntax. It's way easier. This syntax has a couple of names. Anybody know what this syntax is called? Called mustache or handlebar syntax. You may have used it in React. Okay, so Angular uses it as well to delimit or denote a value that's coming, a dynamic value, not an HTML hard-coded text. So we've got this variable called title. So somewhere in our code, this title value is being set as app works. So where do you suppose that would be? So we found our main HTML template, which is index. Yeah, so here's our app component.ts. Here's our title value. Component sets a variable and passes that variable to an HTML template. And our HTML template then can render or display that value. So it's not that different really from when we set a value in our Express controller and pass it to the EJS view to render it. This is the Angular version of the same thing.
I was going to say, kind of reminds me of C# when you had, sort of that view and then you had the logic behind it.
Yep. Not all that different. The way that it makes it more like Express is we're explicitly passing a value, right? And we could pass multiple values.
So the TypeScript file is kind of like your...
Kind of like our Express controller. It handles all the logic.
Okay.
And then decides what view to render. So this is kind of like our res.render statement. It's just a property of the component. When we place this component on our form, what HTML page holds the view?
And the component.html is where the actual...
Yeah, that's the actual UI layer.
Yeah. The markup.
The markup. That contains both HTML and any Angular code.
And then that always gets injected onto the index.html. Is that what?
Yeah, so how does it get injected?
App root.
Notice we've got this app root tag. If we look at the TypeScript file, so in effect, we're defining our own HTML tags here.
So you can change selector to anything.
Right, so let's change this. Instead of calling it app root, this L10 component 1, right? Our first component. So I'll change the selector. So here, now notice what happened when I go back to the browser. Notice now that component doesn't show up. Our Webpack automatically restarts because we made a change in our TypeScript. So it recompiles that change. But notice now our component doesn't show up. Why? Because our index page is looking for some component with the selector app root. Well, that doesn't exist anymore. So if we want to render this component, we have to change this tag to say L10 component 1, as well as our ending. Webpack should restart again. And now when we go back, our component's loading. So typically we'll want to give that selector some kind of descriptive name. So it's just a way to attach a component into our main HTML view. So we may write all sorts of different components, right? If we're doing some kind of video game store, we may have a game component, we may have a customer component, we may have a shopping cart component.
You can just swap in the components instead of going to new pages and stuff too.
Yep. Or we write one component. Yeah, so we can swap out and define what components should load.
Yeah.
If we want to change the HTML in here, we can do it a couple ways. So here, let's change the title. So this will be lesson 10. And notice WebStorm saying, hey, do you want to recompile your TypeScript? It doesn't really matter because my Webpack server is going to recompile it anyway. So it doesn't matter if I say yes or no to this. And by the time we go back, it's already updated. So just like passing a variable from an Express controller to an EJS view, our Angular component, we can set up multiple properties. Like we have a title, we can set up a message.
Makes like editing stuff on the page way easier too. You don't have to reload the page every time.
Yep, that's right. Webpack just automatically reloads it. So now if we want to add this as an H2, notice it says, okay, you've added a message field to our class, but you're not using it yet. Gray, it's not an error, it's kind of a warning. If we go back, we could put on an H2. Now we can display the message. So now we should have a heading and subheading. Once this still says it's unused, it's interesting. That's odd. Why is my message not showing up?
It's supposed to be a comma after title instead of a semicolon.
I don't think so.
That's how the component part's written. So I don't know.
Let me just check. No. I'm not sure why it's not showing up. Ah, there. Just took a minute.
Oh, was it out there?
Didn't compile. I'm surprised it's still saying that it's not used. I'm not sure why. So we can pass as many values as we need from our component to our view. Just like we did with Express controllers, we could pass a JSON object with multiple values to our EJS view, and we could show all of those. Now, there is, actually, there is a style sheet as well. Let's add this. So what we're going to do today, we're going to make kind of a mini version of the game library, but we're not going to use the database at all. We just want to kind of store the games. We'll just create the games right here in Angular. And then we'll be able to look at how do we display a game, how do we display a list in Angular, how do we select one record and display that, etc. And once we can do that, next week, we'll connect it up to the existing back end we've already written. We'll just kind of deal with it in the front end for today. We have a style sheet here. So if you go into index, actually, it doesn't have a list. But the Angular CLI gives us an empty style sheet and says, go ahead, use this as your own custom CSS, put whatever styles you want in here. They have a really good tutorial on the Angular site. We're going to kind of do a similar version, but I've adapted it to work with our video games rather than with the sample they've given. But they gave us a style sheet that we're going to steal. So inside of lesson 10, the second last item on Blackboard says lesson 10 styles.css. Let's download this file into lesson 10 and overwrite the blank styles.css that the Angular CLI gave us. So I'll just right click this one, save it. And it's inside the source directory. So I'll save it and I'll overwrite the blank one that the Angular CLI gave us. So once we include those styles, you'll notice automatically Webpack will restart our server and we've got some CSS. Different font, blue for our H1. That's just defined in their sample. So that index.html, this is kind of like our template for the whole application. So we might put in a nav here, we might put in a footer, we could put in other CSS or JS links, and then all of our templates use them. So instead of like with EJS, we made a separate header and footer and then included them. This is kind of going the opposite way. We have one template file, like an ASP.NET master page, in effect. This serves as like our master file. So anything that should be shared, we could put in here.
So it would be, is it a good practice to add things to this file or create them as a component and ingest them as a dependent?
So like the nav and stuff.
Good question.
Like, would you put the nav in this file and would you put the footer in this file too? Or would you
I think for me, if I was going to make it, I guess in determining whether I would make like a nav component and then include it here, obviously it has to have a tag other than nav because that's an HTML. You know, if I called it like my nav bar or something like that and put it in a component, the question I would ask myself is there any logic to it? If it's just static HTML, I'd probably define it in my template, right? Why use the overhead of generating it in a component, compiling it? If there's really no JavaScript that needs to run. Static HTML, I'd probably define it here. If there was some logic, like I was a CMS, and the links in the nav bar had to be dynamically queried from the database, then I do it as a component. So both would work, but that would be how I would approach it. Some people might disagree.
But also in our case, we have two different navs, which is the login user nav navigation and the output navigation. So there will be a logic.
Yep. Okay. True. Yep. That's a fair point. So it might depend whether that component is static or not. A static component I would just inject here, like a footer, for example. So we've got this, we've got our component, we have some CSS. We can take this out. By default, every time we create a component, it also gives us a particular style sheet for each component. We probably don't need this. If we have 5 components, we're not going to need a new CSS for each component. So we can leave this file, but I could probably take out the link to it. We're going to use one style sheet, kind of our global style sheet, rather than making a new CSS file to go along with every HTML page. Probably no point in that. So I'm going to remove that.
It's just more of an organization thing.
Yep. That would allow us, if we wanted custom CSS for just this page, well, there's a style sheet. We can put it in.
You just delete that line.
Interesting. So what we want to do now is we're going to create one instance of a game We're going to create a class that's strongly typed, and we'll set up the properties of that game. And then we want to display it in our HTML view. And then later we'll change that into a list of games that we can display. So we're going to create a public class called game. This will be very much kind of like our Mongoose model. Right? We created a game schema, and we defined the properties of a game. The fields as well as their type, because we're writing TypeScript, it's strongly typed. So maybe we've got an ID. And we'll just give it a title, which will be a string. So this we can't do in JavaScript. ES5 has no ability for us to create a strongly typed class. But TypeScript will allow this. So now, when we're exporting our component, we want to export not only the title and message, we also want to export our game, and then we can display this game in our HTML view. We're creating a new instance of a game, giving it an ID. Video game title, anyone? What game are we putting in here? Okay. Today we're just creating it in memory, basically, in Angular. We're not going to use the database today. We'll attach this stuff up to the back end next week. So now when we're exporting a class, not only do we have title and message, we're also exporting a game object with these values. Actually, you know what? We'll do it this way. Rather than just calling it a game, I'll call it a featured game, because later on we'll add more games. So Zelda can be our featured game of the week, but we'll add other games as well. So now in our HTML, we should be able to display the featured game as well as the ID and title properties. Similar when we pass like a game object from our Express controller to an EJS view, we could display the game.title, game.id, game.year, etc. We can do the same in Angular. Put on one more heading. Here's our featured game. Oops. We refer to our featured game object, and then we can access the individual properties. Very similar to how we do it in EJS, but again, we're using our handlebars or our mustache delimiters, which are a lot easier. Easier to type and easier to read, I think. If you prefer, you can also put spaces inside of them. That doesn't affect anything. If you find that more readable, to put a space before the value. Okay. We've got our ID. Would help if I put in the proper property name, our featured game.title. automatically refreshes. So if we think about how this might work when we're working with our MongoDB, right? If we look up a particular game record, we can pass that game record to an Angular component, and that component can pass it to a view, say, for editing. So something like this, when I click on one here, I'm going to want to look up that particular, I think I've stopped the server. I want to grab that particular thing and render it into a specific spot on my HTML page. So we're just hard coding the values in, but next week these values, they're going to come from here instead. We're still going to use the model we wrote and most of what's in the controller to go and look up that one game. We're kind of just mocking up the database by storing these values just in Angular memory. So we're really not writing JavaScript here. We're just writing HTML and with HTML with Angular directives and TypeScript for our logic. So today we're just kind of working with these two. And next week we'll add in the service component, which is the interface between the Express backend and our Angular front end. Okay. If it seems like I'm going relatively slowly today, that's intentional.
Services in module, I guess?
There isn't a service here yet. We'll actually create one.
Okay.
I'm going to suggest, I'll just come to you in 1 second. There's a few resources I would highly suggest. I'm not requiring you to look at them, but there's 2 things I would suggest you do before next week's class. In total, it will probably take you a couple of hours. Okay? There's 2 good resources. The first one is right on the Angular.io site. They have a tutorial here called the Tour of Heroes. This is kind of what it looks like. So you get a little nav bar, you get the top heroes, and you'll get something that looks kind of like this, a list. And again, this isn't using the database. All the data is just stored in memory like we're doing now. So I've kind of borrowed a mini version of this for what we're doing today. But it also allows, if you go through this, back in the 5th section, it lets you build a service. Through building the service and how this works, okay? So this whole tutorial, there's 7 sections, will take an hour or 2 to do. But it will increase your comfort level with what we're doing greatly. Okay, so I would strongly recommend taking the time to do it. The other resource that I'm going to point you to that's much shorter, it's like 15 minutes, but again, it gives you practice at creating a component and the syntax around it. On Code School, they have an Angular 2 under the JavaScript path, and the first chapter of their Angular 2 course is free. It's not very long, it's 15 or 20 minutes, but again, it walks you through creating a component using an HTML template and how that works. Now, they also have slides for this, which they let you download. Here's that entire thing as a PDF. So this is on here. It's 161 pages. So here's all the slides. There's like a 10-minute video and then some samples. But it's good because there's lots of visuals. If you really like to see the visual stuff, they have lots of it. Okay, so those things are here to help you. You don't have to do them, but they're going to make this thing a lot easier if you do a bit more between now and next week in terms of practicing with Angular 2. You'll get more out of it. So it's 5 to 5. So I'm going to suggest we'll stop here for 10 minutes. And what we're going to do when we come back is, we're going to kind of create this part. We'll create an array of games. We'll see how a looping structure works in Angular. So how we can grab a bunch of data and render the whole thing. It's a little different from how we did it in EJS. And then if we have time and we should, changes back to our in-memory array. We'll see how much of that we can do before we go today. Okay, I'll push what we've done so far up to GitHub, but we really haven't done a whole heck of a lot. We really just added this and added that. That's it. Everything else, Angular, the CLI built for us. So we've really only put about 8 lines of code in it so far. Okay, let's take a 10-minute break here.
Here's the